Good evening, morning, or afternoon, wherever you are tuning in from on this big, blue marble we call home. Today, we're not just talking about space, we're talking about survival, ambition, and literally punching a celestial body. We're talking about a mission so audacious, so profoundly cool, that it elevates the human race from simple Earth tenants to planetary defenders. The news is out, and it's spectacular. The giants of space exploration are mobilizing. Specifically, we're zeroing in on the monumental plans coming out of China. Academician Wu Weiren, a living legend in China's space pantheon, a man whose career has been built on conquering the moon, has now set his sights on the heavens themselves. He has affirmed that China is dedicating significant resources, time, talent, and treasure, to launch its own dedicated asteroid defense project. Think about the sheer audacity of that statement. This isn't a university research proposal, this is a national commitment to rewrite the ancient, cruel rules of the cosmos. For eons, we have been passive spectators, subject to the whims of the universe. Now, we are saying, no more. But why this sudden, aggressive pivot from exploration to defense? Why the move from photographing the rings of Saturn to actively aiming to smash space rocks? This question holds the key to the next century of human progress. It involves the most terrifying moments of our deep past, the most complex physics of our present, and the most glittering economic promise of our future. Let's start with the big, ugly truth that forced us to build this shield. The indictment of the deep past, when a rock changed everything. We have a precedent, a chilling, 65-million-year-old receipt for what happens when you ignore a massive piece of space debris. I'm speaking, of course, about the Chicxulub impactor, a rock that, by modern estimates, was approximately 10 to 15 kilometers, 6 to 9 miles, in diameter. To put that in perspective, that single rock was taller than Mount Everest. When that colossal object slammed into the shallow waters off the Yucatan Peninsula, it didn't just create a large crater. It created an instantaneous, planet-wide cataclysm that is almost impossible for our modern minds to truly grasp. First, the kinetic energy released upon impact was estimated to be the equivalent of 10 billion times the energy of the atomic bomb dropped on Hiroshima. The very rock of the Earth's crust was vaporized instantly, forming a massive fireball that mushroomed up, punched through the atmosphere, and began raining superheated, molten debris down across the entire planet within hours. Imagine the scene: global wildfire. The sheer friction of the descending ejecta, hotter than the surface of the sun, ignited forests and jungles across multiple continents. This was the first wave, firestorms that spanned thousands of miles. The second wave was the tsunami, an unimaginable wall of water hundreds of feet high, scouring coastlines deep inland. But the true, final killer was the atmospheric dust. The pulverized rock, soot, and sulfuric aerosols lofted into the stratosphere created a planetary veil that blocked out the sun for years. This was the impact winter. Photosynthesis, the very basis of the global food chain, shut down. Temperatures plunged. The giant, magnificent creatures of the Mesozoic era starved in the freezing darkness. The dinosaurs, masters of the Earth for 160 million years, were undone by one bad day in space. This is the grim history lesson that motivates Wu Weiren and all the world's space agencies. We cannot simply sit here, fiddling while the cosmos prepares to burn down our home. We must take proactive steps to ensure humanity does not become the next, slightly smarter, geological footnote. Our mission is to prove that we are not passive inhabitants, but active guardians of this magnificent sphere. The numbers game: why preparedness is not paranoia. Now, let's address the skeptics, the folks who believe the big ones are too rare to worry about. They say, just sit tight, it won't happen for another 65 million years. That, my friends, is a mug's game, a truly dangerous gamble. The threat isn't just the extinction-level event, it's the city killer and the regional catastrophe. Space is a lot busier than you think. The city killer threat, an asteroid with a diameter of just 140 meters, roughly the size of 2 football fields laid end-to-end, is estimated to hit Earth every few thousand years. If one of these strikes a major metropolitan area, the energy released is enough to obliterate the entire region, causing massive loss of life and a crippling economic and social collapse. The Chelyabinsk punch, remember the 2013 event in Russia? That object was only about 20 meters wide. It was invisible to nearly all detection systems because it came from the sun's direction. Its explosion, equivalent to about 30 times the force of the Hiroshima bomb, shattered windows for hundreds of miles. It was a clear, unambiguous cosmic warning shot. The stark reality is that we have already identified thousands of near-Earth objects, NEOs, that are large enough to cause regional devastation. We are constantly searching, constantly tracking. But the universe is a vast, messy place, and we know that plenty of rocks are still hiding in the cosmic shadows, waiting to be discovered. This is why projects like China's are essential. This is the ultimate form of planetary insurance. You buy insurance hoping you never need it, but you absolutely cannot afford to be without it. The cost of a defense program, while high, is literally infinitesimally small compared to the economic, human, and social cost of one devastating impact. The art of the nudge, kinetic impact and orbital mechanics. So, how do we perform this impossible feat of stopping a speeding bullet? It's not with nuclear weapons, as Hollywood might suggest. It's through sheer, brilliant physics, specifically, the kinetic impactor method. The core principle is simple but profound. We don't need to blow the asteroid up, we just need to change its velocity, its vector, by a tiny fraction, miles away from Earth. This is where the butterfly effect becomes our planetary savior. The pioneering mission, NASA's DART, gave us the textbook lesson. They aimed their 550-kilogram probe, our cosmic cue ball, at Dimorphos, the small moonlet orbiting the larger Didymos asteroid. The execution was flawless. The probe, using its autonomous navigation, its onboard super GPS, nailed the target at an astonishing 24,000 kilometers per hour. The outcome was a change in the moonlet's orbit by 32 minutes. This minuscule change, this tiny fraction of a percentage in its overall speed, is what saves the day. If you apply that small push years in advance, the resulting divergence from the Earth's path is measured in thousands of miles. A small action, a monumental result. But the science of the hit was even more revealing. Data from the collision showed that Dimorphos was not a single, solid piece of rock but a rubble pile, a surprisingly fragile collection of loosely aggregated boulders and dust. This was a massive discovery. When DART hit, it didn't just transfer momentum, it created a massive plume of debris that shot out of the asteroid like a powerful jet. This jet acted like a natural rocket thruster, providing an extra push to the asteroid, making the deflection even more efficient than predicted. This new understanding, that asteroids are often surprisingly weak and porous, is vital for China's upcoming mission. It means engineers can design future impactors with greater confidence, knowing that the target will likely provide an augmented deflection effect. The defense strategy isn't just about the strength of our punch, it's about understanding the density and internal structure of our cosmic opponent. The galactic get-rich-quick scheme, asteroids as economic frontiers. Let's pivot from the terrifying to the terrific, from planetary defense to planetary profit. Because these rocks are not just hazards, they are the keys to the next trillion-dollar economic frontier. First, they are scientific goldmines. Asteroids are remnants of the early solar system, largely unchanged by geological or atmospheric processes. They hold pristine samples of the original chemical cloud that formed our sun and planets. By studying them, we gain insight into the violent, churning early history of our solar system and, crucially, the deep, complex chemical processes that may have first sparked life on Earth. But let's talk business. The real excitement lies in the vast wealth locked inside these space objects. We're talking about economic resources that could literally end global scarcity for industrial metals. Asteroids are categorized, and the most valuable ones are the M-type, metallic, asteroids. These rocks are essentially solidified, exposed planetary cores, packed with incredible concentrations of platinum group elements, PGEs platinum, palladium, rhodium. These are essential for nearly all high-tech modern applications, catalytic converters, fuel cells, specialized electronics. On Earth, these are exceedingly rare. A single large M-type asteroid could contain more platinum than has ever been mined in human history. The valuation is staggering. Structural metals, massive amounts of iron and nickel. These metals are crucial for building the infrastructure of the future, space stations, orbital manufacturing facilities, and deep space habitats. Launching 1 ton of structural steel from Earth currently costs tens of millions of dollars. Mining it from an asteroid already in space is the only viable path to off-world industrialization. Water ice. Many C-type, carbonaceous, asteroids are rich in water ice. This isn't just water for drinking, it is the most valuable commodity in space. Why? Because water can be broken down into hydrogen and oxygen, the ultimate rocket fuel. An asteroid with accessible water is essentially a cosmic gas station for future interplanetary missions to Mars and beyond. Mastering the precision required for kinetic impact defense is the essential first step toward asteroid resource utilization. If you can hit it accurately, you can eventually grapple it, tow it, or mine it. China's mission is not just about a shield, it is a geopolitical claim in the ultimate economic race of the 21st century, the galactic gold rush. The Chinese challenge, pioneering the era of planetary stewardship. This, then, is the grand tapestry of the asteroid mission. It is a fusion of survival instinct, scientific curiosity, and economic ambition. China's decision to launch this dedicated defense project is a profound moment in space history. It signifies a full commitment to becoming a planetary steward, a nation that contributes actively to the defense and sustained prosperity of the human species. Their technological prowess, honed over decades of successful Moon and Mars missions, is now being brought to bear on this truly unbeatable challenge. Let's be honest, the difficulty is extreme. This mission requires navigating the vast, lonely darkness of space, autonomously detecting a non-cooperative target, and delivering a precise kinetic punch with zero margin for error. It requires the kind of Herculean effort that defines humanity at its best. But this is what we do. We stare down the barrel of the seemingly impossible and find a way through. We build the impossible. We push the boundaries of physics and engineering because the alternative is unacceptable. So, the next time you hear the words, smashing asteroids, remember the full story. Remember the ghosts of the dinosaurs, the promise of cosmic wealth, and the sheer, indomitable human spirit that refuses to be simply a passive victim of the universe. We are building the shield. We are securing our future. And we are opening the door to a tomorrow where humanity's journey is truly limitless. The space pebbles will not win. Our great story is just beginning.